I am Sarthak Bajpai and I am going to present a seminar on chemical vapor deposition. Chemical vapor deposition, that is CVD, it is a widely used technique to make 2D nanomaterials and thin films on solid substrates. This comes under the bottom-up technique. A material which acts as a plain base is used and our required nanomaterial is grown over it using suitable techniques. This material, which acts as a bottom base, is called as substrate. The precursor is the starting material, which is processed by the means of a chemical reaction used to make nanomaterial. In this technique, the precursor, which may be a gas or vapor, can react or decompose on the pre-selected substrate at highly elevated temperatures and vacuum inside a chamber. In this process, 2D nanosheets grow on the substrate. The reaction may be carried in presence or absence of catalysts. CVD production of graphene. So the very first step is, as shown in the figure, a copper wafer is immersed inside a closed container containing methane gas. The whole apparatus is heated to highly elevated temperatures. Because of the thermal energy gained by the methane molecules, they move randomly and collisions undergo with the container and the copper wafer. At the moment a methane molecule collides with the copper wafer, the carbon atom gets trapped while the remaining hydrogen atoms get freed and keep moving around. In this way, as the reaction proceeds, the number of carbon atoms attached to the copper wafer gets increases. Now the carbon atoms remain firmly bonded to the copper wafer, so it becomes impossible to remove it. Then finally a carbon layer on the wafer is formed. This carbon layer is actually graphene. It is just one carbon atom thick. After that, to transport graphene, it is first given protection by using an organic substance. It is first covered by organic layer of PMMA polymer, that is polymethyl acrylate polymer. Then the substance is deposited on acid. The copper wafer gets removed, but the carbon layer, it remains as it is. Then to remove our nanomaterial, a silica glass slab is used. It is placed below our nanomaterial and taken out. Finally, the carbon PMMA layer is washed in water. This removes all the acid traces which get adhered to the material. When the graphene layer has to be used in the device, the PMMA layer is removed first. It is removed by using an organic solvent, especially acetone, and we have our graphene ready. This graphene is a planar sheet of sp2 hybridized carbon atoms. The lattice of graphene contains each carbon atom surrounded by 3 other carbon atoms in the bulk, excluding the carbon atoms present at the border line of the solid. Graphene is expected to have a number of applications in the fields of nanotechnology and superconductivity. Thank you, sir. This is the end of my seminar.